In this very lesson, we shall be looking at the union and intersection of sets. The union and intersection of sets. So let's start with the intersection of sets. What does it say? The intersection of set A and B is a set of elements that can be found in both sets. It is mostly denoted with this very symbol. It looks like an N. So if you have set A and then set B, then the intersection of set A and B can be written as A intersection B. Similarly, if you have two sets, let's call them set X and then set Y. Then the intersection of X and Y can be written as X intersection Y. Similarly, if you have two sets, let's say P and then Q, then the intersection of P and Q can be written as P intersection Q. Now what this means is that if you have two sets, let's say set A, which contains the elements, and then we have another set B, which contains the elements 2, 3, 5, 6, and then 8. Then A intersection B means that we are going to look through these two sets to see if you have an element that is common to set A and then set B. An element that is common to set A and then set B. Good. So looking through set A and B, realize that we have 2 is common to set A and then set B. You can also see that 6 is common to set A and then set B. We also have 8, which is common to set A and then set B. So all those circled numbers are what common to set A and then set B. And those members or elements becomes the A intersection B. So in listing them, we are going to have 2, 6, and then 8. Very, very easy and then simple. The intersection, it means that we are going to look out for those elements that are common to both sets. And we have 2, 6, and then 8. Let's take another example. Let's take it that you have set X, which contains the elements 1, 2, 3, 4, 5, and then 6. And then we have another set, let's call it set Y, which contains the elements 4, 5, and then 8, and then 10. And then we have to find X intersection Y. So what this means is that we are going to look through these two sets to see if we have an element that is common to set X and then set Y. So you agree with me that 4 is common to set X and then Y. 5 is also common to set X and then Y. I believe that is all. So X intersection Y, we are going to have what? 4 and then what? So this means that these two elements are common to set X and then set Y. Let's take the last example on intersection. So we have our second example. Given that we have set U which contains this element, we have set K which contains this element, and then we have set L which also contains this element. Our task is to find K intersection L and then represent it on the Venn diagram. So first of all, what we are going to do is that we are going to list the element for this sets. We are going to list the element for this particular set. So we have set U. We are talking about what? Integers that start from 1 up to 20. And we know that integers are positive and negative whole numbers. With this, we have, it starts from where? 1. So we are going to start from 1, 2, 3, 4, 5, 6, and then we have K, which contains the element odd numbers, and we know that odd numbers are numbers that when divided by 2 leaves a remainder of 1. So we are going to start from 1, move to 3, move to 5, 7, we have 9, 11, 13, 15, 17. Is that all okay? So up to 17, and then we move on to L. So L, we are talking about what? Prime numbers less than 20. So we are going to start from 2, 3, 5. Good. So we are done with the listing of these elements for each of these sets. What we are going to do is that we are going to find K intersection L. We have K, we have L. So we are going to look out for those elements that can be found in K and at the same time can be found in L. So let's continue from here. So we have K intersection L. So let's look through and then see if we have a common member. So we have 2, we don't have 2, but we have 3. So we have 3. We also have what? 5. We also have 7. We also have what again? 11. We have 13. And then what? 17. So we are going to get 3, 5, 7, 11, 13, and then 17. So all these elements, they are elements that can be found in both sets, set K and then L. Now our task is to represent this information on the Venn diagram. So this is how we are going to go about it. We have our universal sets. How many subsets do we have? We have 2 subsets. So it means we are going to draw 2 circles. And these 2 circles that we are going to draw, they are going to intersect because we have what? An intersection. So it means that we have the first circle, this circle represents set K. And then we have another circle, let's call it set L. Good. So this region is called the intersection. So it means that this or all those elements here, they belongs to K, and at the same time they belongs to L. So this region is called the intersection of what? K and then L. Good. So when representing it on the Venn diagram, the first region that we are going to represent is what? The intersection. So we are going to write all these elements in this very region. Good. So all those elements, all those circle elements have been written here. We are left with what? 1 and then what? 1, 1, 9, and then 15. So we have 1, 9, and then 15. So we have all these circled elements have been written down here. We are left with what? 2, what again? 17, and then 19. And that is that. Let's move on to the union of sets. Union of sets. When we talk about the union of sets, then we are referring to the combination of all the elements within the 2 or more sets. So let's take it that you have set A which contains the elements 2, 4, 6, and then 8. And then you have another set, let's say set B, which contains the element 1, 3, 5, and then 7. Then the union, which is written as this, of A and B, is the combination of set A and then set B. So we are going to combine set A and then set B into a single set. So we have 1, 2, 3, 4, 5, 6, 7, and then 8. So when we talk about the union, it's just a combination of all the elements within the two sets into a single set. So the union of sets is represented as this. So if you have two sets, set X and Y, set X and then Y, and then we have to find X union Y, we are going to write it as X union Y. It means that we are just going to combine all the elements in set X and then set Y into a single set. Let's take another example. Let's take it that you have set. Let's say set A, and then we have set B. Then we have to find A union what? B. So what we are going to do is that we are first going to list the element for set A and then set B. So set A, we have what? Odd numbers. We have to start from 1, move to 3, 5, 7, 9, because we are talking about what? Odd numbers less than 10. And then we look at what set B, which contains the elements even numbers less than 10. We have 2, 4, 6, 8, and that is that because we are talking about even numbers less than 10. Therefore, A union B is just going to be a combination of all these elements into a single set. So we have 1, 2, 3, 4, 5, 6, 7, 8, and then 9. Let's look at the last example and then we run out of here. So we have our last example. Given that we have three sets X, Y, and Z, we have to find what? X union Y. So we have X union what? Y. So what it means that we are going to combine all the elements in X and then Y into a single set. So we have A, B, C, D. Is that all? So we have A, B, C, D, E, F, G, H, and that is what? X union Y. Our next is to find X intersection Y. X intersection Y. What it means is that we are going to look through set X and then Y to see if we have a common element. So let's see if we have a number that is common to set X and then set Y. We have B, we have D, we have F, we have G, and then we have H. So we have B, D, F, G, H. So we have X intersection Y. And then we move on to the next one. We have to find what? X union Y union Z. X union Y union what? Z. So what it means is that we are just going to combine all these three sets together into a single set. So we are going to combine this, and that. So we are going to have, and that is that for X union Y union Z. And then the last one we look at what? Even. X intersection Y intersection what? Z. So we are just going to look through set X, set Y, and then set Z to see if we have an element that is common to these three sets. Do we have an element that is common to these three sets? We have A is not here, but A is here. So A is not part. We have B, and then B. So we have B, and then B. Good. We have C, but we don't have C here. Good. We have G, but we don't have G here. F, and then F. So we have F, and then F. So these elements are common to set Z, set Y, and set X. So we have what? B and then F. So this brings us to the end of today's lesson. I'm going to give you some tutorial questions. Pause the video, you write it down, you try your hands on it.